So let's try to graph 6x minus 2y equals 4 using the slope-intercept form, which is y equals mx plus b. Note that in this formula, m is our slope and b is our y-intercept. If you want to know more about slope, just click the eye icon there at the upper right corner of your screen and you will be redirected to that video. A separate video about y-intercept is there too. Notice that the given equation here is in its general form. If you want to graph this using the slope-intercept form, you have to convert this into that form. That is, you have to have in a form of y equals mx plus b. This gives us a hint that 6x should be transposed at the right side of the equation, leaving us now negative 2y equals negative 6s plus 4. And dividing both sides by negative 2 to have a simplified y, this gives us now positive y equals positive 3x minus 2. If you want to be reviewed on how to operate integers, such as us having a negative 2 here, just click the eye icon there at the upper right corner of your screen and you will be redirected to that suggested video. Now, knowing that the slope would be the coefficient of x, our slope here would be 3, and our y-intercept would be that negative 2, which is the point 0, negative 2. For the benefit of others, when we say that negative 2 is the y-intercept, automatically that negative 2 is our y value and our x value would be 0. Again, if you want to be reviewed on y-intercept, just watch the suggested video there about x and y-intercept. Since we have identified the slope, which is 3, and the y-intercept, which is 0, negative 2, we are now ready to graph the given equation 6x minus 2y equals 4. If you want to be reviewed on how to plot points, just click our suggested video there about plotting points. Let's consider blue color for the point 0, negative 2. Plotting that point will have this. From this point, we will be using the slope, which is 3. In that suggested video about slope, it's discussed that slope would be considered as rise over run. So when we see that the slope would be equal to a 3, and 3 as a whole number, we can rewrite this as 3 over 1. Having now rise, which is 3, and run would be 1. So from point 0, negative 2, we just have to move 3 units up and 1 unit to the right. Again, we have a thorough discussion about slope and about doing this in a separate video entitled Slope, where its link is at the eye icon. So now we have a second point for the equation line 6x minus 2y equals 4. If we want to have another point, we just have to move 3 units up and 1 unit to the right. If you want to have more points for the equation line 6x minus 2y equals 4, you can definitely add points downwards. So how to do that? In the context of slope, when we have a slope of positive 3, knowing that positive 3 can be written as negative 3 divided by negative 1, instead of us moving upwards, this time we will move 3 units downwards, and instead of moving 1 unit to the right, we are to move 1 unit to the left. There you go. So let's continue. 3 units downwards, then 1 unit to the left. So let's label the points that we have here so that it's easier for us to verify its correctness later. One way to verify its correctness would be analytically. That is, for the point 24, we can check if the point 24 would satisfy the equation y equals 3x minus 2. Since the y value for the point 24 is 4, the left side of the equation would be 4. And the right side of the equation would be 3 times x, and our x here is 2. So we have 3 times 2 minus 2, giving us 4 for the right side and 4 as well at the left side. Similarly, if you want to verify the point 1, 1, x here is equal to 1 and y is equal to 1. Substituting these values, we'll have 1 equals 3 times 1 minus 2. We have 1 is indeed equal to 1. Aside from verifying the correctness of the graph analytically using the points that we got through the use of slope and y-intercept, let us check if the method that we just discussed would really be effective in graphing a given linear equation just by using its slope and a y-intercept. Graphing y equals 3x minus 2, we have this. Let's check now the points if they would really be on the line. And to double check if our y-intercept form y equals 3x minus 2 is really just the same with 6x minus 2y equals 4, notice that if we will hide the graph of y equals 3x minus 2 and input instead 6x minus 2y equals 4, the graph of this original equation of the line would really pass through the points, meaning these two lines are just the same.